Have you ever wondered how a computer knows what's in a road? Like how it can tell a dog from a tree or a car from a road? It's not magic, it's called image segmentation. Basically, it's how computers break down a picture into parts so they can understand it. Let me show you how it works. Let's look at the types of image segmentation explained for dummies by a dummy. So there's 5 main types of segmentation: thresholding, region-based, semantic, instance, and the final boss, panoptic. So let's go from the easiest to the most complex. So first, there's thresholding. It's super simple. It's just seeing whether a pixel is bright or dark, and if it's above a certain value, then it gets converted to black. If it's below that, it gets converted to white. So this one doesn't have any machine learning or any smart algorithms behind it, but it works well for things which are under a bright object, under a bright background, and especially for x-ray or document scanning. It's also super fast, although it's pretty dumb for most cases. So let's look at a similar thing, but it's a bit more complex, where it is like thresholding, but similar looking pixels get grouped together, not just ones which have the same value or are above a certain range. It takes into account of texture, saturation, color, brightness, hue, and this one also does not require any training, but it doesn't actually recognize the objects either. Here's an example. You can see that there's black mass around here, so I can identify that and segment it. It's not smart, but it can still look at the textures. Then there's the real smart stuff, semantic segmentation. So here it actually labels every single pixel as a part of some class, whether it be a car, tree, or dog. And this is usually used in self-driving cars a lot, because that's how they recognize if it's a pedestrian or traffic light or anything near them. And this does require training, and it looks at every single part of the image. However, similar objects are given the same label. This is an example of semantic segmentation. One key thing is that even though these are all different vehicles, they are all still given the same red class, which is a vehicle. None of them are differentiated, and that is true for the trees, for the buildings, and the poles. Now we have instance segmentation. It is kind of like, it's like a brother of semantic segmentation, where it does label each pixel, but it also distinguishes them between them, so it can actually count the number of objects in each pixel and doesn't call everything the same class. So however, it doesn't really focus on anything other than the main objects, and it forgets the background and other small details, but it's good for counting. So as you can see here, the original picture must have had 3 goats in it, and with semantic it's all just one big class, but with instance it can tell the difference between each goat. And then we have panoptic, which is the final boss. It's kind of like the parents of instance and semantic, where it just combines them. It can label every single object, but it's also able to find background regions and other small details. But this one's also very complex to train because it requires way more data. So over here you can see the main difference between panoptic and instance, where it has the same people and it can count different objects, but in instance it just leaves the background. But with semantic and panoptic, it does look at the background, and this is the original image. And if you're a real one who stuck around till the end, here's a secret about image segmentation that nobody knows about.
Psych!